So this week, it's not just Shubs and I. We've got Adam with us. So Adam is one of the security researchers who works at Assetnote. Um, uh, does amazing work in terms of finding new vulnerabilities, 0 days, reversing patches, really bringing in that, I guess, offensive security capability into our platform. So, welcome, Adam. Thanks for coming on and having a chat with us. One of the things that we wanted to really talk about is the ServiceNow vulnerability. So we've been kind of tight-lipped about it since it came out, but we're now able to talk about this publicly. And you were the one who found it, and it was a great vulnerability. So maybe we can start by diving in. How do you approach looking at something like ServiceNow from a research perspective?
Thanks, Michael, for the introduction. So when we look at ServiceNow, it's a huge Java monolith application. So it's over 20 gig of source code. So it's a huge thing to tackle, and you can't just go over the application line by line. So you need sort of a strategy on how to approach it. And when I look at a big application, what I like to understand is the routing. So if I visit the index page, which path through the code is that taking? What is actually handling the index page? And if I go to, for example, /admin, or I go to one of the pages for configuration, how is that actually being handled, and what checks are being done? Can those checks be bypassed? Things like that. So for ServiceNow in particular, it turns out that they don't use a web.xml configuration like you'd see in a lot of other Java projects. In fact, ServiceNow is a very customizable application. And as part of that, the requirement for a lot of ServiceNow users is that basically any route can be customized to route to any page and render any content. So instead of being like static and all defined in Java, it's all defined in very dynamic sort of configuration files. And in the case of ServiceNow, it's defined in these tables that you can configure as an administrator. So that was how I started looking at ServiceNow. And my attention turned to, well, how is this configuration done? Is there any way to bypass any of the checks that are being done in terms of permissions? And what is actually happening there?
Great. So you kind of approached it initially looking at all of these sort of dynamic routes and things like that. How did that, what kind of, I guess, triggered there to based on what you were exploring there to sort of get you thinking about the actual vulnerability that you found? Like, how did that start to connect through?
Well, as I started looking at the way the different routes were handled, I found there were sort of like broad categories in how routes were handled. So there were like special cases. Some routes were handled like internally via Java code. So they had very specific paths. Those were sort of the hard coded ones. And then you had ones that were like almost API endpoints. So you hit them and you get back a JSON response. And those didn't look too interesting to me, at least initially. But then I came to the UI side. So a lot of the routes that are handled, like for example, if you go to the login page or the welcome page, that they render a page that's meant to be viewed by the end user. So I began to look into how that worked. And there's this whole configuration language that they've built, which is custom to ServiceNow, based on this technology called Apache Jelly. And it seemed to be rendering stuff from templates. And not only was it doing it via templates, but there was some extra scripting going on, and there were things being injected. And so eventually I was like, well, maybe I'll be able to find an XSS. And I started looking at the configuration language, but the more I looked at it, the more I thought maybe this is not just an XSS, maybe this can actually be leveraged for something more. So that's why I began looking at that.
That's a really good point. How do you kind of approach this idea of going for more, right? Because, this is a common, I guess, thing that happens with security research, right? Especially when you're looking at something big, you maybe get to a point where it's like, I think there's XSS, right? Or I think there's something like that. But you kind of have a hunch that there may be more. Like, at what point do you kind of stop and give up versus go on?
Yeah, that's a really interesting point. So I think for these big applications, I think something that's not talked about a lot, but it's nice to be able to get a bit of confidence with a big application. So when you're looking at a big application, sometimes you have the feeling that a lot of people have looked at it before. So maybe like you're not going in with the best mindset in terms of expecting to find something immediately. And so looking for something small like an XSS as opposed to going for RCE right away can be quite good for just getting your confidence up. Okay, this application isn't infallible; it has bugs. And then once you find that first bug, like even if it's really small, even if it's something really lame, that then chips away at the application. You know, well, yep, there are bugs to be found in this application, so maybe we can start looking for something more.
Yeah, cool. So you had that gut feel that I should be looking for something greater than XSS here, and so take us from that point. Where did you go next?
So I found an XSS quite quickly. Uh, there's the templating language that they use has a way to determine if something is not escaped, and if it's not escaped, obviously there's an XSS, and you can pass user input into it. So I was pretty happy with that. But when I found that, something that struck me as weird was if I passed in an XSS that wasn't valid XML, like it wasn't valid HTML, I would get a server error. And that was strange to me because that would seem to mean that something was happening in the backend that was parsing whatever I was passing in. And so I then began to think, well, what exactly in the backend is parsing this? Isn't this like a front end templating language? Why is the backend parsing my input? And so then I began to dig into the code to understand, okay, how exactly does this templating language work? Is there anything that can be leveraged there?
Great, great. And so once you started to look deeper into the templating language, you came across some issues, right?
Yes, yeah, that's correct. So
So yeah, let's dive into some of those issues and like because this is now getting to like the crux of the bug, right?
absolutely, absolutely. So the interesting thing about ServiceNow is that the templating language is actually it's a two-tiered templating system. So what it will do is it'll take a template, it'll pass the user input in, run the template, and then what it will do is the rendered template will be repassed into the template engine again, and then that will finally come out. So input is passed twice, and that means that if input gets injected in like this first phase, we'll call it, then that can be interpreted by the second phase. And if you've been doing, bugs for a long time, you know that template injection is one of the more serious sort of bugs you can have because it can lead to code execution. And ServiceNow had a bunch of protections about they had obviously thought of this scenario, and so they had done some sort of like blacklisting. And so it became a case of, okay, how exactly have they blacklisted the templates? What can we do? But by tracing through the code that we found a mechanism by which we could inject XML, which will then be passed again via the template system. And that led to code execution. So actually, this XSS, quote unquote, which was then being repassed in the template system, led to RCE.
Right. So can you talk a little bit about initially some of the protections that they had considered as part of this sort of double evaluation, and then what the actual bug was, and how we were able to then exploit that.
Sure. So Apache Jelly is an XML based templating system. So many modern Python ones, they use like curly braces or stuff like that. Apache Jelly is XML based. And as part of that, the tags that get interpreted have a namespace. So I believe it's like J colon is the prefix for something from a jelly tag. And then when Apache Jelly parses that, that will be handled specially. If you have something like a script tag or whatever, that's just seen as HTML, so that's just left alone. So basically, if we can inject something with that prefix, so we can inject XML with that prefix, we know it's going to be interpreted by Apache Jelly. What their protection was they actually blocked that prefix, quote unquote, called J2 from being executed. So two phases. J1 is the first phase, so that's running the first phase. We don't have any control over that. J2 is what is checked for in the second phase and executed. And that's what we sort of needed to bypass, the idea that we couldn't inject anything with J2 in it because that would be blocked by ServiceNow. That was their sort of mitigation against this vulnerability. What we discovered was that by using XML feature where you can specify a namespace, we could specify a different namespace to the J2 namespace and execute code under that. So even though they had called their second phase J2, we could rebind that namespace to our own namespace, let's say a colon, and then execute that. And by doing that, we could bypass their protection and basically include any script code that we wanted.
Right, right. So now at this point, you've got injection, right? Effectively, right? What's sort of the steps from there, right? So in terms of thinking through, the impact of this, right? So what can you do now at this point, with this vulnerability?
Sure. So credits to ServiceNow, they do have like a multi-tiered sort of layer of security. So even though we now have script execution, that doesn't mean we've pwned the box or anything like that. We have access to their own scripting language called Glide, and Glide is built on Rhino, so it's a JavaScript based sort of language for touching all parts of the ServiceNow application. And that attention then turned to, well, we have this Glide execution. What does it actually allow us to do? Um, Glide is used everywhere. It's used for reading from tables. It's used for doing configuration, making HTTP requests, stuff like this. And there's over 1,000 Glide classes. So it really became a case of, well, let's grep through the documentation, let's grep through the source code and see what we can do. And what we sort of discovered is that there are some classes that touch the file system. In particular, it can be used to read the configuration files for the instance. And if you can read the configuration files of the instance, you can pull things like database credentials to connect directly to the database, which is obviously very serious. And we also found that in some cases, under certain configurations, you can execute commands on any proxy servers that are configured. So ServiceNow, being a cloud application, may not have access to your internal network. So you may want to configure a proxy server, which sits in your internal network and funnels data back and forth between your company network and ServiceNow. We found that ServiceNow, through this scripting language, gave us the capability to execute any command that we wanted on these proxy servers. And because they're inside a company's internal network, that can actually be quite serious. So it was
Yeah,
simply a matter
yeah.
of just of
That's
reading
the
the
real kicker
documentation at
with
that point.
this. Yeah, that's the real kicker with this vulnerability, right? Because you're using like an external product, right? But through this mechanism, basically just by use of this product, now you've exposed your internal data and your internal networks and systems, right? So,
Absolutely.
so that's kind of massive with this bug. Yeah. Cool, cool. So yeah, so end to end, you work through ServiceNow. Do you have any kind of overall thoughts on how it was working on this vulnerability and doing this research?
Yeah, it was very fun. I love working on big projects because they give you a lot of freedom to what to look at. I believe this really hasn't gotten the attention from the security community that it would, I think, deserve. So I'd be curious to see other research in ServiceNow. And yeah, it was a great time working on it.
Cool. Yeah, I think the interesting thing about this bug, and it goes to something that Adam said earlier, is just this idea of when we're talking about like your confidence to keep going and look at new bugs, is that it's a big application, so it's probably had many eyes over it and things like that. And I think that's probably an assumption that maybe doesn't hold true, right? Obviously, I think a company like ServiceNow, they have a lot of security folks, and they are doing this kind of process, but it is also very large, very very complex product that is actually hard to get access to, right? Usually you have to pay lots of money to get access to this sort of stuff in general, and so I don't know necessarily that it's been looked at in as much depth, perhaps as sort of some other systems. And I think this raises a really interesting point, given sort of the impact. And we talk about it at Assetnote a lot, just this idea that companies and organizations are running this kind of software, right? Whether it's ServiceNow, whether it's some other vendor product, and the security for those teams is it's kind of opaque, right? They don't have like Adam on their team to look at the security of these in the kind of depth that these products that to the depth that Adam has. Whether it's the resource or the capability, and often they're looking at like high level markers, that go to a bit more of a sense of security than really looking at like the actual security. And it's kind of interesting because when you think about concepts like shadow IT in a way, people often think about it's the infrastructure that the marketing team has set up for some website, or it's like some IoT device that somebody's plugged into their network. They don't think about this sort of stuff as being shadow IT. And in some ways it's not, right? Because obviously, they go through a contract and probably pay bajillions of dollars for this sort of software, right? So it's not shadow in that sense, but it's shadow in the sense of security. So I mean, maybe like a better way to describe it might be like shadow exposure more so than shadow IT. But um, it's kind of really interesting if you look at sort of the research that we've done, and why we focus on this sort of software. It's about bringing that to light and showing organizations the kind of exposure that exists in their attack surface just by virtue of using these products, that often they don't really get a perspective on, because they don't have, guys like Adam on their team at the end of the day. Cool. So, uh, yeah, I think Adam, I think we can kind of call it there. So thank you for going through the bug. It's really great work. And so yeah, awesome. Thanks, mate.
Thank you so much for having me on.
Cool. So yeah, Shubs, well, I mean, what do you think about that kind of concept, right? Because you've been doing a lot of research as well, uh, and just in terms of this kind of idea of the hidden exposure that's in these modern attack surfaces.
Yeah, well, there is so much hidden exposure, and to be honest, sometimes you'll find that this hidden exposure is in some of the most popular software and widely used software out there. Right now, as a security research team, we're dealing with reverse engineering patches in Apache, which were dropped by, or the bugs were dropped by Orange. And Apache is probably one of the most popular and most widely used software there is on the internet when it comes to a HTTP server. So it's kind of like this concept of, there's bugs and everything, but how much you know about these makes a huge impact and difference on what you can protect and what you can do. And really what I see as a function of our security research team and what we do at Assetnote is bringing that visibility into areas that you aren't actually really aware of, or thought that there were vulnerabilities in or issues in that were serious. And this is, bringing it back to just what you spoke about with Adam, this is a big reason why we focus on ServiceNow. I mean, it's one of the most popular technologies and used by almost every large enterprise in this day and age. And I think that there's this real, uncertainty around how secure is it really. And this is something that we wanted to focus on to see, okay, well, we have most of our customers that are using this. We should probably really take a deep look into this and make sure that there is, there is that due diligence done on our side as well.
Yeah, and it's not just ServiceNow, like specifically. I mean, just in general, it is this kind of software, right? That whether it's SaaS software, whether it's an appliance that's sort of deployed inside the attack surface, it's full of a modern attack surface is full of this sort of stuff, right? And the security of it is just really opaque, and I think one of the challenges is just the way that teams are set up to identify this stuff is just not really that effective in general, right? It's security questionnaires, it's third party attestation, it's really high level kind of stuff, and it doesn't go to the nuts and bolts enough. And And when you think about some of the impact of this, right? Like this is critical infrastructure when you really think about it. When you think about the kinds of functions that these systems are serving, the kind of data that's being processed or stored within these systems. At the end of the day, it's critical infrastructure, and so it kind of needs to be treated that way, but it can't be because often the vendors of this software are like, hey, you're at arm's length, right? Which is not so bad, right? There is part of the reason why you pay for an external product is they can manage it and they can deal with it and they can do updates and whatever. But on some level, that doesn't necessarily mean it should extend to the security, right? And it's really hard for organizations to get a real good sense of if I'm adding this to my attack surface, what kind of exposure do I have? And what I find really interesting is there'll be kinds of really detailed process for the stuff that they develop themselves, right? They might do code review, they might do pen testing on an application. They'll run through all kinds of checks and tests, but then they'll spend seven figures and buy something else and just chuck it in their attack surface without anywhere close to that level of rigor. And it's in there alongside these applications, alongside this stuff, and it's just a real gap, I think. and
Mm.
and so that's why in a lot of ways I think it's the real shadow IT, at least from a security perspective, right? Even though it's
Yeah.
known, it is really opaque.
Yeah, I agree with you. And look, I'm not going to dive too deep into this topic for this podcast, but there's also a huge element where when we talk about hidden exposure and shadow IT, a lot of these companies have bug bounty programs for their vendor products. And more often than not, these bug bounty programs are actually a mechanism for these companies to hide this exposure from the general public.
Mm.
One, it usually shuts down any sort of public disclosure from the researcher when it comes to writing about the issue unless they get explicit permission, which isn't always possible in these programs. As well as, in many cases, what I've seen is organizations aren't even really issuing the necessary CVEs or advisories when something critical is reported to them via a bug bounty program. And this is probably the most disappointing part because it means that, often there's exposures that no one knows about except for the company and the researcher, which means that everyone is less secure as a result of it. So it is a tricky part, but it kind of adds to this hidden exposure part that I'm trying to get to, where
Yeah.
we're not always sure about what's there underneath a product or what has been there underneath a product
Yeah.
because of various mechanisms that make it possible for companies to not really have to disclose that.
Yeah, I mean, I think that's kind of an interesting point that's worth reiterating is that we do hear or see, I guess when these sorts of vulnerabilities, whether they're, in these sort of really widely deployed, heavily used, systems and software, right? Whether it's Apache, whether it's ServiceNow, whether it's Citrix or something like that, we do see. The various folks on the other side, right, who are defending against this, kind of call out that kind of transparency, whether it's you shouldn't be doing publishing deep technical research, you shouldn't be publishing POCs, you shouldn't be doing all that kind of stuff. All that does is help attackers, right? And I get where they're coming from, right? Like because for something like this, again, because it's critical infrastructure that they're running their attack surface, and then that now, and they've become aware of this exposure and this risk, they've got to deal with it, and they've got to deal with it quickly, and that's just the nature of the game. But I think the interesting thing is I don't actually think that that's helping attackers, right? By keeping it, by putting it out there. I think what's helping ultimately keeping it quiet is helping vendors more than it's helping anybody else, because a vulnerability doesn't come into existence because a security researcher found it, right? That's not how this works. The vulnerability gets added through mistakes, oversight, whatever, into some software, and then a security researcher finds it, right? And that could be present in that software. That exposure could be in that software for years, right? And just because somebody hasn't published it, just because a good faith researcher hasn't disclosed it to the vendor, or the vendors discovered it themselves, doesn't mean it's not an exposure, right? It's still there. And I think, pushing back on that transparency that you speak of is kind of, it's just in service of the vendors supporting this sort of opaque system, as opposed to holding them to account a little bit on security, and perhaps forcing them to be a little bit more open. I think, that's where sort of what we do comes in a little bit, in terms of, for our customers at least, right? Going through this stuff and saying, like, look, this is the true, exposure that you have in your attack surface, and these are the things that you can do to fix it. You don't have to rely on anybody else, right? You can identify this, and have it fixed, and when everybody eventually starts freaking out about it, you can sleep well at night because you've already dealt with it. And I think, that's what people want, and that's sort of a little bit more how it should be. But you can't fix something if you don't know it exists, right? You can't deal with
Yeah.
it if you don't know it exists. And so I
But
think it's important to shine a light on it.
yeah, for sure. But there's been this interesting trend, I would say, in the last 5 to 10 years, where you've got these really big monolith applications that were typically on premise, that have moved onto a hybrid of cloud versus on premise, and then eventually phasing out the on premise and having cloud only, SaaS only, basically. But one of the things that always annoys me a lot is when I'll see like an advisory from one of these companies that have an on-premise version and a cloud version. And in the advisory, they'll say cloud was never affected. Cloud has always been secure. There was no vulnerabilities in cloud, even
Yeah.
though literally like the code base is basically the same thing with minor modifications. And I know for a fact several times where I have discovered an on-premise vulnerability, I have been able to usually reproduce it on cloud with minor modifications.
Mm.
But the marketing we see in this day and age is a lot of these third parties that are now on the cloud will say that cloud is a much more secure alternative, and cloud is much more protected than the on-premise installations. But honestly, I struggle with that a little bit because the vulnerabilities are still there. And once they phase the on-premise, it's just going to be harder to find them. So it's just it's one of those things where I think it's just adding to the point of hidden exposure.
Yeah, I mean,
And
I can see both directions. I can see the direction you're coming at it from, to a certain extent, is the security researcher angle, right? Where it's like you can lock down the cloud a little bit more, from that kind of perspective, and then it's harder for security researchers to find bugs. But I can also see the perspective of, a lot of the challenge with this sort of stuff versus the cloud is how quickly things can be patched and addressed. And I mean, we saw it with ServiceNow, right? I mean, they jumped on this straight away, and like within hours of the report, they'd hot fixed all their cloud instances, right? And so there is that kind of perspective.
yeah, there's real benefit for sure. I'm
Yeah.
not going to deny that. I'm just trying to say that sometimes you will see vendors that say cloud was never affected, and we
Yeah,
both
which
know
is
that's not.
probably not true. Like, let's be
Yeah,
let's be real. Like, it probably is affected. It's usually the same software, right?
yeah.
But they can fix it quick enough that they can keep up the perception that, if you pay us for a cloud, version of this, like, it's more secure. And in some ways, it is may be true, but not quite, how you're phrasing it, right? Where it's like, yeah, look, they're still vulnerable, but they're able to address it very quickly on your behalf, and they have systems for it that may be more effective than you, if you're managing it yourself, right?
But all of this, right? All of this, I think, just contributes to this hidden exposure that we've been talking
100%.
about. And I do think that it's going to be extremely common for vendors to start moving to a cloud only solution for most of their software. That's not going to stop. Like on-premise software is not really something that's taking off in this day and age as much as
Yeah.
cloud is. And when that happens, and as that happens, and it already is, it is going to be harder. not only for us to discover these vulnerabilities, but also for us to understand where the exposure is
Yeah,
for
and
our
I think
customers and our customers in general.
yeah, and one thing for companies to just be really aware of is at the end of the day, you can outsource the management of this sort of software, but you can't outsource the risk, right? Like the risk is still yours, and the exposure is still yours. So you need to be conscious of it. You need to understand that, these systems. It's great. Okay, you're outsourcing the management of this, the security of this system, the patching of the system, whatever. But it's still part of your attack surface, and there's still potential exposure there, and you still need to consider what that is, and understanding that, so you can manage that as effectively as you can. Because, as I said, yeah, you can outsource the day to day, but you can't outsource your risk at the end of the day. So, yeah, this is a really, really kind of deep topic. There's a lot of interesting elements there. I think things are shifting though, right? Would you say that that's fair? Do you think both from the vendor side and the sort of the end user side that things are shifting? We are seeing a lot of vendors sort of whether they're sort of more modern vendors, right? We see particularly in the bounty space, right, where they're very open and transparent. They've taken the perspective of, well, what you're paying for us is effective security management and oversight, and that includes responding to these sorts of security reports in a mature and effective way. But even legacy sort of vendors, right, that have a history that may not have that kind of culture, they're kind of getting to that point. And then also on the organization side, they are demanding more of that from their vendors, right? Are you seeing that trend to a certain extent, or do you still think it's a bit antagonistic, and it's not really trending towards transparency?
Well, when it comes to transparency, yeah, I am seeing it, and all the vendors that you expect to do a good job at writing advisories and releasing information about the vulnerabilities are doing it, with the caveat of some really large companies that I'm still shocked that don't have any advisories for their issues.
Mm,
But I will say, when it comes to transparency, or even just this, and this is probably a broader topic, but even this idea of identifying this hidden exposure and reporting it to companies, I am seeing more and more often these days that these sorts of reports are being knocked back. Like, let's say you find a 0 day in a vendor product and you report it to some bug bounty programs. Then these days there are now community guidelines on HackerOne that prevent this from happening, as
yeah.
well as companies having stricter policies. Now, I don't know if that's necessarily exactly what you were talking about, but I think that when it comes to this ecosystem, I think it's important that companies that run such vendor software and accept the risk, which is what you were saying earlier, take responsibility for the risk as well. Because, for example, if I spin up some software on my infrastructure and it leads to my entire network getting owned, and someone finds a 0 day and reports it to me, well, that was risk that I accepted. I spun up the infrastructure. I have it on my attack surface. That's an issue in my attack surface, as much as it is an issue in the vendor product.
Yeah, I
At
mean,
least that's
it
how I
may
see
not
it.
be risk that you've accepted, but it's risk that you've taken on for sure,
Yeah,
right?
yeah, for sure.
And that you do have to manage, and like you can't just bury your head in the sand for it, right?
Yeah,
I mean, I do get from a bug bounty perspective why it's a bit more nuanced, but I do think in general, like people are, the end users, right, are looking for more of this kind of insight into
yeah.
what they're running. I think the challenge with the bounty approach for this sort of stuff, and I can understand why, is just that the economics of it don't necessarily make sense, right? Because if they're having to pay out for multiple instances of it, they've got nothing they can do about it until there's a patch. And then even if there's a patch, right, there's potentially, if you are the person who's found the 0 day, it's potentially not cool, not giving them enough time to deal with it, right? And
I
so I
mean,
can see their perspective,
I,
but
I
I can
definitely think
also
that
see
could be a
yours as
whole
well, right?
podcast in itself. To be
Yeah.
honest, I think we could talk about that for a long time. But But yeah, I guess what I was trying to get across is like this idea of accepting or taking responsibility for the risk, even if they don't know of the risk. And that's, that's maybe not exactly what I'm trying to say with the bug bounty stuff. I'm just trying to say it's not really a registered risk. It's not really something where people come into this saying, "Ah, yeah,
Well,
I've deployed this vendor software. I know that there might be problems here
and
that could
that's
lead
kind
to
of the
us."
point. Like they're not then you can't manage a risk if you don't know what's there, right? And like
Yeah.
how do you do that, right? And I think a lot of the ways that are that companies use to try and get a sense of this, it's not really that great, right? It's a one-off vendor security questionnaire when they onboard a vendor. It's looking
Mm.
at self attestation, like even SOC 2, right? To a certain extent, right? Is kind of it's kind of limited, right? It's not deep technical. Like, I mean, you obviously are very familiar with the work that Adam did, right? But that kind of depth, nobody can do that really. Nobody has the resources to do that for third party products. They've barely got the resources to do it for their own stuff that they're
Mm.
developing and putting out, and that's kind of where their focus is going to be. But so they are. I think a lot of folks are looking for a better way to get a sense of this, and they are looking for these hidden areas. To the point of bug bounties, I'm not sure that bug bounties are make the most economic sense as a mechanism to do that, right? But I think there are other things that people are looking to do to try and get a sense of it. But yeah, absolutely, to your point. I mean, you can't just ignore it at the end of the day. You can't hope that nobody finds anything or puts it out there. You have to acknowledge that this is part of your attack surface. You own the risk of this as much as anybody else, right? Because the impact is yours at the end of the day. If somebody exploits some third party software in your attack surface, and compromises your data, or whatever they do, that impact, that outcome is yours, right? You can't say, well, that was somebody else's software. It's like, no, this is in your attack surface. So the bare minimum, you want to have visibility into what that potential exposure is, and then ideally visibility into the actual exposure, so you can address that in the same way that you would address it in any other part of your attack surface. And I think people are moving towards that direction. I think people are understanding that. And
Yeah,
so
I think actually, like the most mature companies these days have already transcended that point, and at
yeah,
that have been at that point for quite some time. And what we're really seeing, and what I'm hoping for, is more of the, I guess the small to medium sized companies really get there as well, or even that market that's kind of not quite as mature as the really big companies, but trying to get there. And I think this is a part of that. I think a part of it is understanding, oh, okay, like we might have accepted risk by deploying these things on an attack surface. What are these things, and how can I test for my exposure for these things?
yeah.
And that's really important. And that's, as you said, not every company is going to be able to afford a security research team focusing on vendor products. But that's where, we have teams like ours, which actually focus on this as their full time job to
Yeah.
try and bridge that gap and that discover that hidden exposure.
Yeah, I agree. I think this is where things are trending. I mean, there may be an element of sort of confirmation bias because the kinds of people that use our product, right, and buy our product are looking for this, right? And they are
Hmm.
thinking about this. But I think the kinds of companies there, tend to lead the pack, in terms of the folks that we're working with, and I am seeing it sort of filter down into sort of that larger mass market. And people are looking for it, whether they're getting it or whether they're able to effectively achieve that outcome yet. I mean, it depends, right? But I think at the very least people are looking for it. So that's kind of been an interesting trend to watch. But yeah, you're right, we could talk about this forever. I think it's been a good chat. It was great getting Adam on. I'm always kind of just shocked and impressed at the quality and the speed of the work that they do, right? To go to the level of depth that they go to focus on getting an understanding of like the actual true exploitability of an issue and the actual true impact of an issue in such a short period of time is always fun to watch. But yeah, so it was great having Adam on. But yeah, man, I think we can call it there.
Sounds good. Let's
Good
call it.
chat.
Good chat.
Cool.